As we continue our tour of the elements, we come to the largest family, and one that makes up some of the most interesting elements on the periodic table. The 29 transition metals. They split the main group into two parts and form the transition between the electropositive families here that have electrons to share, the positively charged ferrocious metals, and the electronegative families here that want to borrow electrons, like the halogens and nonmetals. They are all metals. And what defines a metal? Well, you might think a definition of a metal is a very scientific and hard-to-grasp formula, like a metal is an element or a chemical compound whose atoms readily lose electrons to form positive cation ions. And yes, well, that is a scientific definition of a metal. But scientists also define metals by how they appear or behave. In general, scientists define a metal as something shiny and dense, something that conducts heat easily, like a pot or a pan. It conducts electricity well, like wires, and they can be easily shaped without breaking. Just exactly what you always thought a metal was. Many transition metals are household names like iron and zinc and mercury. And you've probably at least heard of tungsten, titanium, and chromium. But others like rhenium or hafnium or osmium are virtually unknown to anyone who is not a scientist or who has not watched Chemistry 101. They are numbered in families 3 through 12. And while there are complex patterns in each column, especially electron configuration, there are several groups within the transition metal families that are straightforward and quite interesting. At least a little more interesting than just electron configuration. Now, IUPAC. IUPAC is the International Union of Pure and Applied Chemistry, and it is the recognized authority for all chemistry standards. And IUPAC does not require or even recommend a specific format for the periodic table, and there is a lot of latitude in how people can group the elements together. That being the case, here is a quick overview of the Chemistry 101 transition metal groups. Then we will look at them in more detail. The alloy metals. Even though all metals form alloys, groups 3 through 6 are especially useful in forming essential alloys with iron and other elements. The magnetic metals. Iron, cobalt, and nickel are the magnetic metals. They are the only pure elements that are magnetic and that can be made into permanent magnets at room temperature. The noble platinum metals. Just like we have non-reactive noble gases over here, so there are also 6 non-reactive noble metals clustered down here, right under the magnetic metals. Coin metals. Group 11 contains the world-famous coin metals, copper, silver, and gold. The zinc-link group. The zinc-link group is the last stop before the poor metals. They are the link between the transition metals and the poor metals. The zinc-link group. Finally, the fountain pen group. Okay, this really isn't anywhere near an official scientific group, but I found it interesting that within the platinum group there are 3 elements with characteristics that make them ideal for use in fountain pen nibs. Scandium, from Scandinavia, where it was discovered. Scandium has few commercial uses and it is expensive to produce. Lightweight alloys are its primary use. Yttrium, from the village of Ytterby, Sweden, where it was found. In fact, the little village of Ytterby, Sweden gives its name to no less than 4 elements on the periodic table: yttrium, erbium, terbium, and ytterbium, And yes, they all sound very similar and thus are slightly confusing. They were all found in this famous little mine just outside of town, long since shut down and overgrown. 4 other elements also were discovered in the Ytterby mine: gadolinium, holmium, scandium, and thulium. And if that wasn't enough, the entire country of Sweden holds the world record for element discovery, 20, followed by Britain with 19. Plus, it's just plain fun to say Ytterby, Ytterby, Sweden, and the Ytterby mine. Lutetium is sometimes classed as a transition metal, but usually it is with the rare earths, and later that's where we'll look at it. Titanium, a name arbitrarily borrowed from the Greek myth of the Titan giants, because they didn't know what else to name it. Seriously. Strong as steel but much lighter, titanium alloys are everywhere, from jet engine parts to artificial joints and in making white paint. Zirconium is Persian and means looks like gold, and some zirconium crystals have a gold hue and are cut like gemstones. Zirconium alloys are important in the nuclear industry and for jewelry. Hafnium, the Latin name for Copenhagen, where it was first discovered, almost identical to zirconium above it, and is also used in nuclear reactors and to control the fission rate of uranium and plutonium. All 3 elements in this alloy group are named after a mythological Greek god. Vanadium, named after the Scandinavian goddess of beauty, Venetis, due to the beauty of its compounds. It is essential to human life in minute quantities. And a touch of vanadium makes steel strong enough to make armored tanks. Niobium. Niobium and the next element, tantalum, are so similar they were named after a mythological Greek family, the daughter Niobe and her father Tantalos. Pure niobium is completely non-toxic and harmless to the human body, which is why earrings and nose rings and other jewelry are made from niobium. Tantalum. Tantalum is from Tantalos, the mythological father of Niobe. This character Tantalos was punished by being unable to quench his thirst or his hunger, and in a similar fashion, this element is unable to absorb any acids. It is completely immune to even the strong acids. It is similar to niobium in nearly every way, and tiny amounts of tantalum are in the capacitors of virtually every cell phone and computer in the world. Chromium, the Greek word meaning color, because chromium compounds are intensely colored, like these chromium solutions. Chromium is added to steel to make corrosion-resistant stainless steel. Chrome plating makes metal very shiny. Molybdenum. Molybdenum is the Greek word for lead, as this element has been confused with graphite and lead throughout the centuries. Molybdenum is a high-strength, high-temperature alloy and lubricant. To live, you will need about 0.3 grams of molybdenum in your lifetime. Tungsten. Tungsten means heavy stone, as it is a very dense metal. It is often called wolfram, meaning wolf's foam, from the foam that forms during tungsten extraction, thus the letter W for wolfram. With the highest melting point of all the metals, tungsten can be heated white hot without melting. The filament in most common household light bulbs is tungsten. Manganese. The origin of the name is complex, but ultimately it is from Latin mangus, meaning magnet, even though manganese isn't magnetic. Manganese is not only essential for all living things, it is absolutely essential for the production of all iron and steel alloys, making it more yielding and workable. Technetium. It is Greek meaning artificial, as it was the very first artificially made element. Technetium does not occur naturally, and it is the first radioactive element in the table. The glass in this ampule is darkened from absorbing technetium radiation. It is a short-lived element used in specialized X-rays as it attaches itself to active areas of bone growth, and in a few hours, technetium breaks down to stable elements and is eliminated from the body. Rhenium, named for the discoverer's homeland in Germany along the Rhine River. Rhenium was the very last natural element to be discovered, and, of course, it was the most difficult to find. As a result, rhenium is one of the most expensive metals, selling at one time for $5 million a pound. Currently, around $10,000 a pound. Very small amounts of rhenium make exotic alloys that withstand stress and heat, used, for example, in some military jet engine parts. While nearly every element can be influenced by a magnetic field, these three neighboring elements, iron, cobalt, and nickel, are the only three magnetic elements. The reason these three elements are so magnetic is not completely understood, but their interaction is so dramatic and their magnetic effect so strong that we generally just think of all the other elements as simply non-magnetic. Iron. The Eiffel Tower in Paris is made entirely of iron. Iron's symbol is Fe from the Latin ferrum, meaning iron. The English word iron is a bit obscure and probably means strong metal, to contrast it with the weaker bronze metal. one of the oldest and easily one of the most important of all the metals. 90% of all metal refined in the world is iron. Iron can be permanently magnetized. But iron is most valuable with added impurities. A little carbon turns iron into steel. A little chromium makes it stainless steel. The uses of iron are almost endless, plus it is essential to all life. Your body needs about 4 grams of iron to continue to live, about the same weight as this iron nail. Cobalt. Oddly enough, the word cobalt is related to the word goblin, meaning evil spirit. Most cobalt ores contain arsenic, and smelting them produced nasty, poisonous fumes. Cobalt has many uses and has been used for centuries to give a beautiful cobalt blue color to glass and glazes. Most cobalt is used in producing magnetic high-strength superalloys. And if it wasn't enough that cobalt means evil spirit, its next-door neighbor, nickel, means the devil's copper, as the ore was easily mistaken for copper. And after a great deal of work, when miners could not extract any of the copper from the ore, they felt the devil was playing a trick and deceived them, and so they named it Kupfernickel, meaning the devil's copper. Most nickel is made into stainless steel and superalloys for jet turbines. Nickel is the third of the natural magnetic elements. The U.S. nickel coin, however, is not magnetic, as it is an alloy of only 25% nickel and 75% copper. Older Canadian nickels, however, were 100% nickel and would readily jump onto a magnet. Just as we have 6 noble unreactive gases over here, so the metals in this group contain the 6 noble unreactive metals. They are also called the platinum group, as they are all found in the earth grouped around the metal platinum and in the same ores. They are ruthenium, osmium, rhodium, iridium, palladium, and platinum. They are resistant to wear and chemical attack and don't combine readily with other elements, just like the noble gases. This is why these metals are often found in laboratory equipment and in catalytic converters. They don't easily combine with other elements. Ruthenium is the Latin word for Russia, the discoverer's home country. Ruthenium comes from platinum ores and is, of course, one of the noble unreactive metals. It is also one of the rarest metals on Earth, thus expensive and useful. Adding just 0.1% of ruthenium to titanium makes titanium 100 times more corrosion resistant. This is also one of the 3 fountain pen metals. The famous Parker 51 fountain pen is tipped with a 96% ruthenium nib. This, by the way, is a fountain pen. It contains an internal supply of ink drawn to the nib through gravity and capillary action. They are comfortable to write with and have a sense of timeless elegance about them. Although ballpoint pens easily dominate the market, millions of fountain pens are sold every year, and many of their nibs are made with ruthenium. Osmium. Osmium has a distinctive sharp smell, similar to ozone. Osmium means a smell. Another noble platinum and a very rare element. This is an unusually beautiful sample of osmium crystals. Osmium is a very wear-resistant, tough metal, Thus, it is used for instrument pivots, and it is the second metal used in fountain pen nibs. Rhodium. Rhodium means rose in Greek because the first known compound was a beautiful rose-colored. A member of the platinum group, rhodium is a very noble metal and won't even react with fluorine. Whoa! Rhodium is often used in catalytic converters because of this noble property. A hot catalytic converter converts toxic gas molecules into water vapor and oxygen. Unburned toxic nitrogen oxide molecules enter the tubes in the catalytic converter, which are coated with a noble platinum metal, like rhodium. By simply touching the metal, a chemical reaction takes place and the toxic nitric oxide molecules separate and recombine into harmless nitrogen and harmless oxygen. The noble platinum metal never changes. They just cause the change. They are a catalyst that converts toxic molecules into harmless molecules. Iridium. Latin for rainbow, as many iridium compounds are colorful. It's the same root from where we get the word iris. Aside from radioactive elements, iridium is the rarest of all metals in the world, with rhodium above it coming in a close second. Asteroids, however, seem particularly high in iridium metal. Corrosion-resistant and able to take high temperatures, tiny bits of iridium are used in spark plug contacts. Ruthenium, osmium, and iridium are dense, hard, and wear-resistant metals, perfect for making fountain pen nibs. Plus, these two, iridium and osmium, sinking down at the very bottom center of the transition metals, are the most dense natural elements in the universe. Because their metallic structure is so incredibly tightly packed, they are twice as heavy as lead. A 6-inch cube of iridium or osmium would weigh as much as an average adult. Palladium. Palladium was named after the asteroid Pallas, which was also discovered in the same year of 1803. Pallas was the Greek goddess of wisdom. Palladium is shiny like its next-door neighbor silver, but it doesn't tarnish like silver. It is also about 40 times more expensive than silver. Being a noble metal and a platinum group member, most palladium is used in jewelry and surgical instruments and catalytic converters. Platinum, a name derived from the Spanish word platina, meaning silver, as platinum is often mistaken for silver. Platinum is a noble metal and the namesake of the platinum group of noble metals. Platinum is about 200 times more expensive than silver and usually twice as expensive as gold. Platinum behaves much like gold. It is as corrosion and tarnish resistant as gold, and they are equally rare. A very noble metal used in catalytic converters, jewelry, and scientific instruments. Now we come to the coin group, the metals most commonly used to make coin money, or at least they're the metals we wish our coins were made out of. In low denomination coins, there is the risk that the value of the metal in the coin will exceed the face value of the coin. The U.S. silver quarter is worth many times its face value, so quarters today are a copper coin with a nickel-copper plating that looks silvery but only costs about 8 cents to produce. Likewise, many lower denomination coins are made of steel or zinc with a plating of copper. Interestingly, the coin metals are also the best known conductors of electricity in the known universe: copper, silver, and gold. Copper from the island Cyprus, where ancient copper mines were located. A soft, easily worked metal and one of the first and most important metals worked by man. The Statue of Liberty is covered with copper plates, which turn a green tint after exposure to the moisture in the air. Add a little tin to copper and you get hard bronze, a main candidate for ancient weapons. Add a little zinc to copper and you get corrosion-resistant brass. At one time, pure copper nuggets could be found just lying around on the ground. Electrical wiring is the primary use of copper and in alloys like bronze and brass, and of course, to make coins. Silver. It is uncertain what the English word silver actually means, but the symbol Ag probably comes from Latin argentum, meaning shiny white, and for which the country of Argentina was named. Ores rich in silver largely disappeared years ago from extensive mining, and today silver is extracted as a byproduct from mining other metals. Plus, with the advent of digital cameras, the demand for silver for making film stock has dropped 50% in just a few years. Sterling silver contains 7.5% copper for added strength. Electricity flows through silver more easily than it does through any other metal. Silver has been used for centuries for jewelry, tableware, and of course, for coins. Gold. Gold means shining yellow. The symbol Au is the Latin aurum, the golden color of the morning dawn. Gold is the most malleable and ductile metal in the world. This 1-ounce piece of gold is ductile enough to be drawn into a wire 50 miles long without ever breaking and beaten into a sheet nearly 100 feet on each side. Gold and silver are often added alongside the 6 other noble metals. Since gold is non-toxic, very thin gold foil leaf is used as a decoration on chocolate and cake and eaten as a delicacy. Gold is dense, almost as dense as iridium and osmium. And gold is rare. The total amount of gold ever mined in human history would fit on a volleyball court cubed. Enough gold has been mined to only build 1/3 of the Washington Monument. Jewelry is the single largest use of gold. One of the most ancient metals, gold has been used for centuries in jewelry, artwork, industry, and of course, for coins. The final transition metal group is the zinc group. The zinc group forms the link between the transition metals in back of them and the poor metals in front of them. In fact, some periodic tables will color the zinc group as if they are a transition metal, and some will color them as if they are a poor metal. They are softer than most transition metals, and all three have low melting points, very similar to the poor metals to come. They are the zinc-link metals. Zinc. Zinc is a gray metal with a bluish tinge and was known to the ancients, but the meaning of the word zinc has been lost to history. Rusting metals cost billions of dollars to replace and to repair. The primary use for zinc is in electrically coating or galvanizing other metals to prevent them from rusting. Zinc and copper can be alloyed together to make brass. Plus, zinc and copper can work together to produce electricity. All you need is a little acid. Take a single lemon and roll it to get it juicy inside. A galvanized nail is coated with zinc, so that gives us our zinc metal. Push it into one end of the lemon. Make a small cut in the other end of the lemon and push a penny into it. The coating on the penny gives us a little bit of the copper metal. Like Alessandro Volta's pile, these two metals, with a bit of acid, produce a measurable electric flow. In this case, a lemon battery with enough current to run an LED light. Cadmium. Cadmium is mostly found in zinc ores, including calamine, which cadmium was named after. From the same ore, cadmium and zinc melt at different temperatures, providing a way of separating the two metals. By far, the most important use of cadmium is in the production of nickel-cadmium batteries, NiCad batteries, also called rechargeable batteries. Care must be taken when handling cadmium, as cadmium is a known poison. Cadmium was also a popular compound in brightly colored paints, especially cadmium yellow and cadmium red. Cadmium yellow was a favorite pigment of Vincent van Gogh, and most of his paintings have a distinctive yellow tint to them because of the element cadmium. Mercury. The symbol for mercury is Hg for the Greek word hydrargyrum, meaning watery silver. You can see it in the word hydra argentum, watery silver. It is often called quicksilver, silver that runs. Mercury is the name of the swift-running messenger of the Greek gods. An element known from antiquity and, according to the chemistry division of the Los Alamos National Laboratories, refined mercury has been found inside Egyptian tombs dating to 1500 BC. Five metal elements are liquid around room temperature. Francium, which melts at 81 degrees Fahrenheit. Cesium at 83 degrees. Gallium melts in your hand at 86 degrees. And rubidium at 102 degrees. But only mercury is liquid at the standard room temperature of 70 degrees Fahrenheit, or 21 degrees Celsius. And it is very dense. Lead and iron float in mercury. Heating the ore cinnabar releases mercury as a vapor. As the vapor cools, the mercury is captured as a liquid. Mercury is used in thermometers, in tooth fillings, and in the separation process of making chlorine gas. But mercury and most of its compounds are extremely toxic. As a result, nearly all uses of mercury are slowly being phased out.